If I look at 0 radians, on your 0, sine of 0 is what? Is 0, because it's all the y's, correct? So on my unit circle, I actually don't care what the x is here, I care what the y is, because sine answers are all the y's on the outside, correct? So sine of 0 radians is 0. So that's why I get it starting at 0, 0, the graph. Now, teaching you how to make the tips, okay? So I see there's 0, I see there's pi over 2, I see there's pi, and they can make their x-axis. If they give you a graph, a Cartesian plane, they can make the x-axis be in whatever units they want and make the ticks be whatever they want, correct? But right now, I just see a pi and a pi over 2 and whatever. The easiest way to figure out what your actual tick is worth is to find the pi first and then just count how many spaces it takes you to get to pi. So for example, 0 to here is 1 space, 2, 3, 4, 5, 6 spaces, correct? It takes 6 spaces to get to pi. So pi is technically cut into 6 cuts, correct? So how do you cut? You divide. You divide it by 6 cuts. We agree? So the first one here would be 1 pi over 6. Then the next one would be 2 pi over 6. But what is 2 pi over 6 reduced to? Pi over 3. So this one was 2 pi over 6. I'm just writing this down here so you can see. So this one was pi over 6, 1 pi over 6. This was 2 pi over 6. This was 3 pi over 6, which reduces to pi over 2. This is 4 pi over 6, which reduces to 2 pi over 3. I just want to put the reduced ones up here, so I'm writing the other ones down here. This is 5 pi over 6, which doesn't reduce, so it just goes up here. And this is 6 pi over 6, which is pi. And then honestly, you just keep going. So as long as you figure out what the space is, now it's 7 pi over 6, which doesn't reduce. Then 8 pi over 6, which reduces to 4 pi over 3. Then 9 pi over 6, which is 3 pi over 2. Then 10 pi over 6, which is 5 pi over 3. Then 11 pi over 6. Then 12 pi over 6, which is 2 pi. So you see how I labeled it? And then we're going to put the stuff in between. So we get pi over 6, which is here. What's its y? A half. So at pi over 6, at pi over 6, sine of pi over 6 is a half. So I go there and I make this be a 1, this be 0.5, this be negative 0.5. And these will stay at these values unless you have translations, like unless you stretch it. Vertically stretching it will move that negative 1 and 1, right? By shrinking it or making it taller. So we have 0 with pi over 6 and a half. And then in between those, we actually have pi over 4 if we want to put it. It's root 2 over 2, which is 0.707 something. So in the middle here. Pi over 3 is root 3 over 2, which is 0.8660. Somewhere in there. And then pi over 2, it's something and 1. So do you see how I'm getting the y values that go with it? It's just the sine values, sine of 0, sine of pi over 2. Like you're just giving me the exact values at those places, right? So if I asked you now for sine of 2 pi over 3, what is sine of 2 pi over 3? Not 3 pi over 2. 2 pi over 3. Yeah. So it's at 0.8660. Then we can do the 5 pi over 6 if we want. Sine of 5 pi over 6 is here. So this one was 3 over 2. This one is a half. So sine of 5 pi over 6 is a half. We're literally just getting the exact values at those places, right? All those trig ratios. What's sine at pi? Something and 0, so it's sine of pi is 0. Now we're going to the negatives because our y's are going to be negative now. So this one is 7 pi over 6, so it's going to be at negative a half. So negative 0.5. This one is at negative root 3 over 2, or negative 0.866. Then 3 pi over 2 is at negative 1. So we're just taking the y values. And then this one is negative root 3 over 2, or 0.866. This one is negative a half. And then we're back to 0. Now this isn't a mountain. These are hills. If you look at your graph, does it go like point, and then point, and then point? Is it like pointy? Is the graph pointy? No, it's rounded. So should yours be. So it curves, cuts through here, and down. What's going to happen after that? Repeat, 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 correct? Over and over and over and over. It's a cyclic function. It just keeps going and going and going. And all sine and cosine graphs can be repeated by anything that has a max and a min that does not change. And it just goes max, min, max, min, max, min, max, min, max, min. So anything circular will do that, right? Min to max, back to min to max, back to min to max. And if it keeps doing that circle, then it's just going to keep doing that. You could have a circle within a circle. So like a Ferris wheel within another Ferris wheel. You could have one Ferris wheel going one direction, one Ferris wheel going the other direction, embedded in each other, and you would have two sine graphs, a sine and a sine, or you could have a cos and a sine, okay? Now, another thing that people don't think of is something that's not circular, which would be like a pendulum. A pendulum would also work for these because it would do what? Max, min, max, max, min, max. Like, so it would be max, min, max, min, max, min, max, min, max, right? So you're still doing the same thing. You're literally going from a max to a min to a max to a min to a max to a min. And if you keep doing that and your max and mins don't change, it can be represented by a sine or cosine graph. Okay? Now, let's discuss this one. So there's something called the period. The period is the length of the interval of the domain over which a graph repeats itself. So how long horizontally it takes till it repeats itself. So this graph, what we drew, hadn't repeated itself yet, right? It was all still different. I went up, and I went back down negative slope, then back up to a positive slope, and then it would repeat itself, correct? So how long horizontally did that take to happen? Yeah. 2 pi. So every sine graph has a period of 2 pi or 360 degrees. Can anyone tell me, using transformations, how we could change that? What transformation would cause it from being like 2 pi or 360 to something smaller, or 2 pi and 360 to something larger? Yeah?
A horizontal stretch.
A horizontal stretch. A horizontal stretch completely changes it. If you have a horizontal stretch by a factor of 2, instead of it being 360, now it's going to be 720. It's just going to take longer for that curve to happen, right? And if your horizontal stretch is a half, instead of it being 360, it's now going to be 180. It's just going to repeat faster, right? That's all it does. Horizontal stretches just affect the period because they can shrink it or make it happen longer, right? Okay, amplitude is half the difference between the max and the min. So you can literally use this formula. which is the absolute value of the max minus min divided by 2. And it's the absolute value because your amplitude is always positive. I'm going to write this here so everyone remembers that. Amplitude is always positive. Absolute value of max minus c. Every day. Awkward. You missed it. It's Mitch. He stands there and waves every day awkwardly. And then eventually leaves. I think he does it to play with my emotions. All right. So, in this case, my amplitude would be the absolute value of the max minus the min. What's the min? -1 divided by 2. So it would be the absolute value of 2. Absolute value just turns anything negative positive and keeps anything positive positive, right? Because the definition of an absolute value is the distance from 0. So -2 is 2 from 0, positive 2 is 2 from 0, therefore the absolute value always makes it 2 because it's just the distance from 0. So we're going to get 2 divided by 2, which is 1. Now we could have just figured it out in this one because it's half the distance from the min to the max, so I can just count it. From the min, it takes me 1, 2. Well, what's to the max? So what's half of that? 1. So you can just count it and then count from min to max divided by 2. Sometimes the min to the max are like decimals and weird, and therefore it makes it harder. People like the formula. But often I'll just count. 1, 2, 3, 4. Okay, divided by 2, it's 2. The amplitude is 2. So the amplitude is from your midline up and your midline down. Now what the heck is the midline? The midline is the line that cuts the graph in half horizontally. So it's that middle line. As you counted your amplitude up from it, amplitude down from it, you get it. Yep.
Can we just think of that as the x-axis and be with it, or is that incorrect?
The midline?
Yeah.
It's the x-axis if you have no somethings. What could make you have the x-axis not be your midline? What kind of transformation? Nope. Vertical translation. A vertical translation, pull it up off the x-axis or pull it down off the x-axis, right?
Oh.
So your midline is the x-axis, you're right, if there's no vertical translation. A vertical translation will take it and pull it up, take it, push it down. So, speaking of which, that's this part at the back, right? That's your vertical translation. We agree? This one doesn't have one. So that means my midline, which I'm going to write here. And do you see how it says midline? See how there's the word line in it? In order to make a line, you have to have like an X or a Y. That's the only way you can make a line. If you just say 0, that's not a line, it's a number, correct? So a midline, and it's a horizontal line. Horizontal lines are Y equals or X equals lines? Y equals lines. Because the x-axis is y equals 0, the y-axis is x equals 0, right? So all horizontal lines are y equals. So this midline would be at y equals 0. Okay, what was the amplitude of that graph? It was 1. What's the domain of that graph? I feel like a conductor.
XER.
Yeah, XER, because it's just boom, 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 goes on for life, right? So remember, that's why in chapter 4, when we started in chapter 6 some solving, that's why I had to give you a limited domain. If I didn't give you a limited domain, you had to give me general solution because the graph just keeps going, keeps repeating, keeps spinning, right? That unit circle keeps going. So it's x such that x is an element of the reals in set notation. In interval notation, that's negative infinity to positive infinity. What's my y-intercept at on the graph? 0, 0. And what was the period of the graph? In this one? 2 pi. Now we don't write the 360 because it's always based off of the x-axis, right? If the x-axis is in radians, we answer our stuff in radians. If the x-axis is in degrees, you answer in degrees. And how do you know it's in radians? It doesn't have a degree symbol. So sometimes it'll be in decimal radians, right? But you'll know because there's not little degree symbols behind it. Now what's the range of the graph above? It
is less than or equal to y is less than or equal to positive 1.
Yeah, we sandwich between -1 and 1. So in set notation, it's a bit harder. We have to do y such that -1 is less than or equal to y is less than or equal to 1, yer. And do you know why you do less than or equal to signs twice? For range? Do you know why you do less than or equal to signs twice? Yeah, because you read from the variable. Your inequality signs are read from wherever the heck the variable exists. That's why a big number eats, crocodile eats number, alligator. Like, that's great until you get to variables. That's great until you get to variables. So what we're saying is y, and you can still use your analogy of the bigger thing eats the bigger thing. The crocodile eats the bigger thing. I don't use the analogy, but yeah, you can use it. Because y is supposed to be greater than or equal to -1. So it's eating the y, right? And then y is less than or equal to 1. Do you see why they're actually in the same direction? Because you're reading from the y value, not from left to right. Now we say it from left to right. We go -1 is less than or equal to y is less than or equal to 1. But the reason why the symbols are the same is you read from the y. So y is greater than or equal to -1. True that. And then y is less than or equal to 1, which makes sense. And that's why they're in the same direction. You don't just memorize and understand. It makes life better. Don't make as many oopsies. Then you can, if you get interval notation, you throw a party in your head because it's just -1, 1. You go from the lowest number to the highest number. If you ever write 1 to -1, stop yourself. It's always, interval notation is easy because the smaller number needs to be on the left, larger number on the right. Okay? Now theta intercepts. Where's my first intercept at? 0, then the next one? Then the next one? Then the next one? Can we go this way? To the left? Yeah, what would be the next one? -5 then? Then? This one's too aggressively hit my desk. Okay. See? Linebacker right there. Thank you. Running back for you, linebacker. Okay. That desk didn't see it coming. I stopped it. And I even moved it. Thank you. Was that pretty good?
Yeah.
It was a hip check more. I don't think you really do that in football, but I'm really good at it. Okay. So we can't just say 0 and pi and 2 pi and -2 pi, and like we'd just be writing. We can't just go dot, dot, dot. Okay? I know in the past we've dotted ourselves out for life. Like just dot, dot, dot. We can't do that. We have to state general solutions, correct? And the general solution always starts at the smallest principal angle, and in this case the smallest principal angle is 0. Do I have to write 0? No, I'm going to write to prove a point, and then I'm going to take it away. So, the first smallest principal angle is 0. Then the next one happens at what away from it? Pi. And this way, correct? Pi. So we do pi n, and then what the old curriculum used to do is plus or minus pi n, n-e, w. You used to do whole numbers, and then you would, the plus or minus sign would take into account the integers, right? But in this curriculum, we go plus pi n, and then we go n as an element of the integers, and the integers inserts the minus sign in, because when you multiply by -1, you'll minus pi, right? Multiply by 2, you minus 2 pi's. Make sense? You can keep the 0, you are not wrong, but the multiple choice answers and numeric response will not. They'll go pi n and yeah. Okay, does everyone have sine x sitting in their calculator? I need to get my calculator out. So we have sine x in your first one, cos x in your second one is what I told you to do. And then we make sure we're in the mode of radians is what I wanted you to do because that's the mode we're sitting in. Oops, that says function. That's not what I want. And then we press zoom trig. We only press zoom trig after we've picked our mode. Because if we pick zoom trig and our mode was radians and we switch it to degrees, you now have a window in radians and the calculator sitting in degree and things go badly. You often won't see anything. Okay, for our welfare, the blue is the sine x, the red is the cos x. Remember I told you that if you have two graphs and you don't have a color, I always make my y2 be the thicker one, because once they're drawn, you don't really know which one's which anymore, right? And in this case, they for sure look the same. So I always go over to my, the line over here where the red is, and I would click it once, and then it would be thicker. I have colors, so it makes a difference. So the blue is the cos graph, and the red is, the blue is the sine graph, and the red is the cos graph. Do you see that? They're actually the same graph. They're just a what apart. They're pi over 2 apart. They're a horizontal shift apart. Okay? So we're going to be rebels without a cause. I want to get the cos graph on... Oh, new board doesn't let me do this. I want to get this cos graph, the red one, to be the blue one. What's am I going to do?
Shift it to the right, pi over 2.
Okay, let's try it. We're shifting the cos to the right, pi over 2, correct?
Yes.
So I'm going to go to little graph 3 here. And I'm going to shift the coast, yep. I'm going to shift the whole coast of Canada somewhere else. Okay, I need to subtract pi over 2. Why am I subtracting pi over 2? That is not a pi. Why am I subtracting pi over 2? That's how you move it right. It is true. Could I put it in brackets like this? Should I? Yeah, that's the only way you calculate this fraction. Or use the alpha y equals button, or alpha link if you have the colored ones, right? Now I'm hoping blue gets replaced with black. Okay, now I want the sine to become the cos. What do I have to do? Shift it to the left, add. Then make it purple. Sine x plus over top of it. Miraculous. So the sine and cos graphs are literally a pi over 2 shift of being each other. Correct? Which makes sense, because if you pi over 2 shift it, you switch your things. So we're going to do the cos graph. We're going to flip to the cos graph now. Now, for our y values, what do we actually look at this time? The x's, which is the most confusing part. Sine, okay. Cosines get all confusing. So, I want, I'm going to label these first. So this is pi over 6. Ooh. Pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6, 4 pi over 6 is 2 pi over 3. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 is 4 pi over 3, 9 pi over 6, 10 pi over 6 is 5 over 3, and then 11 pi over 6. And I always label my whole axis to help me out. So at 0, we're going to look for cos of 0. What's cos at 0? 1, because it's actually the x values all the way around the unit circle. So now the x values all the way around the unit circle, actually my y is on the graph. Correct? So cos of 0 is 1. Cos of pi over 3. I mean pi over 6. Oops. Cos of pi over 6 is, yep. 3 over 2. I set you up for failure because I said it backwards. So 0.866. So actually, the sine graph starts at 0, 0. The cos graph starts at 0, 1, right? Because it's that 90-degree or pi over 2 shift. Then we go to pi over 3. And cos of pi over 3 is a half. Then we do pi over 2. Cos of pi over 2 is what? I mean, yep. Then we're heading into the negatives, which makes sense because cos is negative in quadrant 2 and 3, right? Because x is a negative in quadrant 2 and 3. So then we do cos at 2 pi over 3 is negative a half. Cos at 5 pi over 6 is negative root 3 over 2. Negative 0.866. Cos at pi is negative 1 because it's here. Then cos at 7 pi over 6 is negative root 3 over 2. Oh, I really squished that. Negative 0.866. Then at 4 pi over 3, it's negative a half. At this one, it's negative 1. I mean 0. Oh my gosh, I'm struggling with them. This one's negative half. And those are straight and nice curves because it's hard to do them smugly. So we go from a max to a max, right? When we're on a cos, if it hasn't been shifted. What's the thing that would make my amplitude get bigger? Vertical stretch. So if I'm at 1 and negative 1 and I vertically stretch it by 2, my amplitude's now 2, right? If I vertically stretch it by half, my amplitude's now a half, because you're literally just taking that ones and pulling it higher or lower, and you're taking half of that. So this one has an amplitude of 1. You can use the formula. You can go max minus min divided by 2, which is 2 divided by 2, or 1. Or you can count half the distance from the min to the max. The distance from the min to the max is 2. Half of that is 1. Domain doesn't change, right? What's the only thing that's different on this one? There's 2 things that are different, actually. Yeah, and? Yeah, and the theta intercepts, the x-intercepts. The y-intercept of this one is at 0, 1. Not 0, 0. This one has a period of 2 pi because the x-axis is in radians. It has a range from negative 1 to 1 still. The only thing this is a horizontal phase shift. They call it horizontal phase shift and vertical displacement instead of vertical translation and horizontal translation. It's the only unit that they change it to wording. Where did my theta intercept start at? Pi over 2. How far does it take to get to the next one? Pi, because that doesn't change. It just shifted it, right? The difference of when your theta intercepts happen doesn't change. It's still periodic. It's just been shifted. So instead of it being at 0, 0 now, it's been shifted. So it's going to be at pi over 2. I'm sorry, theta equals pi over 2 plus pi n and yeah. And then we talked about how they're just a pi over 2 shift from each other, right? Great. This talks about how your amplitude is the max minus min divided by 2. In the formula, when you look at the formula, y equals a cos b theta and y equals a cos b theta or sine b theta, your absolute value of your a is your amplitude. Which makes sense, because your amplitude is how much vertical stretch happened. If you're at 1 and negative 1, and I vertically stretched it by 2, I'm now at 2 and negative 2, which is an amplitude of 2, because the distance from negative 2 to 2 is 4, and it's half that. So actually your vertical stretch equals your amplitude. Because your vertical stretch is never negative, correct? Your vertical stretch, we never state the negative. The negative causes a what? Reflection in the x-axis, correct? So our vertical stretch is never negative. So our amplitude is never negative. So our amplitude is just equal to our vertical stretch. They're just the same thing. And the period is influenced by the b value. Why the heck would that happen? We discussed this already. Say I have y equals sine b theta. You can use the formula. The formula is 2 pi divided by the absolute value of b, or 360 degrees, symbol should be there, divided by the absolute value of b. You can do that and get your new period. But why is that? Well, let's think about it. I'm going to use a 360 for an example. 360 degrees divided by the absolute value of b. That would be b over 1, wouldn't it? Do you agree? When you divide by a fraction, what do? You flip it. So it would be 360 degrees divided by 1 over b, or sorry, multiplied by 1 over b. What is 1 over b? The horizontal stretch. What did you say would affect the period? Multiplying by the horizontal stretch, didn't you? You said if the horizontal stretch is 2, my period would go from 2 pi to 4 pi. If the horizontal stretch was a half, my period would go from 2 pi to 1 pi, right? Because you're just multiplying by the horizontal stretch. We agree? So either you memorize it as, or learn it as, you can use these formulas, but you're just using b. You're not using the horizontal stretch, correct? Some people will go and use these formulas and then put the horizontal stretch in. Is that the horizontal stretch? No. So either you use those formulas and you divide by the absolute value of b, which is indirectly multiplying by the horizontal stretch, or you just multiply by the horizontal stretch, right? Don't commingle them. People will go divide by the horizontal stretch, and I'm like, backwards it. So you can either do p equals 2 pi divided by the absolute value of b, oops, or you could do p equals 2 pi times the horizontal stretch. Do we agree? Those are the two things you can do. You can either go 2 pi divided by b, or 2 pi times the horizontal stretch. You cannot mix the two, because b is not the horizontal stretch, correct? 1 over b is the horizontal stretch. So either use 2 pi divided by absolute value of b, or 2 pi times the horizontal stretch, but do not use this formula with the horizontal stretch. B is not the horizontal stretch. B is b, 1 over b is the horizontal stretch. We agree? Do you understand the difference between the two? Because I have people mingling them, and then things go really badly. So, I want you to give me the amplitude and period of this one and this one, because there is no, like, normally you'll look behind it and there'll be like a plus 30 degrees or something like that. Then you'll know it's in degrees. Or the plus pi over 6, then you'll know it's in radians. Because they didn't, I would have to specify. I want this one in degrees, which only the period is affected in degrees, right? The amplitude is just a distance. It's 1, 7, 9, 3. It doesn't have any units. And I want this one in radians. So I want the amplitude and the periods. So the amplitude, now I'm writing amp because it's my notes, correct? But on a test, any test, I have to write amplitude. Because amp is actually a standard measurement, correct? Not amplitude. Amp stands for amperes, right? So you can't use amp and then be like, they know what that means. They won't give you the mark. You need to write amplitude. There's no place to put short form, okay? You don't want to lose 0.5 because you short formed a word. That would be the saddest day ever. It's not a day to save your pencil lead, okay? You can save your pencil lead on your notes, but on any test, you write out the word. It's not worth chancing it. So I can write amp because these are my notes. Amplitude equals vertical stretch. I can write VS because these are my notes. On a diploma or on a unit test or on a cumulative, I would write vertical stretch. Even if you write vertical wrong, we've discussed this. I do not care. Okay, if you write vertical under the guise of horizontal, that will not work. Like if you're like, but I wrote vertical. I'm like, but it spells horizontal. But no, but that's just my spelling of vertical. That won't work. Okay, it has to start with a V, or it's not going to happen. So our amp equals our vertical stretch. Our vertical stretch is 2. So our amplitude, I'm going to prove that I can write it out because I'm a rebel without a cause, is 2. So our amplitude for this one is what? Equals a half. All right. Then I need the period. So I can do it 2 ways. I'm going to show both because you could have picked whichever one you wanted. This one has to be in degrees. So I can go 360 degrees divided by the absolute value of b. Well, b in this case is 3. That is the absolute value of b. So I can go 360 degrees divided by 3, and I get 120 degrees. Or I could have went 360 degrees. P equals 360 degrees times the horizontal stretch, right? So I could go 360 degrees times, what's my horizontal stretch? Not 3. My horizontal stretch is 1/3. Now, if my horizontal stretch is a fraction below 1, my period should be getting smaller, correct? If my horizontal stretch is greater than 1, my period should be getting bigger. It should make sense when you get a period. If you're like, horizontal stretch is 4 and you're getting a period of 2/3, be like, something seems fishy here. Okay? So I go 360 times 1/3 and I get 120. Same answer. I don't care which route you go. I care that the answer is correct. I do care that you don't put the two together and make your own version, which is not correct. That doesn't work that well. Okay. This one I said in radians. So I could go 2 pi divided by the absolute value of b, and b happens to be a half. So that's 2 pi times, instead of dividing by half, it's 2 pi times 2/1, which is 4 pi. So I could have done that. Or I could have went, the period is 2 pi times the horizontal stretch, which is 2 pi times, if b is a half, my horizontal stretch is 2. Is there ever a time when my horizontal stretch does not flip from the b value? No, there's never a day. So if you are taking the horizontal stretch and you're not flipping it, you're wrong. Like you're not like, well, maybe this time I'm right. No, wrong. Okay? Horizontal stretch always flips. If you're like, I wonder if it always flips. Okay? So we're going to multiply by 2/1, which is 4 pi. Same answer. We agree? Okay. So we're going to look at 2 cos x. And we're going to look at y sine 3x. And we're going to look at cos 1/2. Do you see those? I think there's some down here. And these ones? I want you to answer them. And we're going to do the transformations tomorrow. So I literally just want you to do amplitude period. Amplitude period. That's all I want answered. And then for tomorrow, amplitude period. Nothing else answered. Don't want anything else filled in. Don't really care about this. We're going to fill it in tomorrow. And then for these ones, I want you to do amplitude period in degrees and radians and the horizontal stretch factor. I want you to do the whole chart. Okay?
The first one is in degrees or radians. Or the graph above that.
The period? Sure. We're going to go back to it. I'm going to go degrees. And then I'm going to go radians. And then I'm going to go, I bet you can guess, degrees. Okay? Don't fill in any of the rest of the chart. I just want that filled in for tomorrow. If you don't fill it in, you're going to just fill it in quickly as we go through it tomorrow. So that's the first thing we're going to go through tomorrow. And then we're also going to do all the translations with it. And then we move on to, what do you think? The other 2 translations, right? We're just doing, we have A and then B. We're also going to have a C and a D. So we're actually doing the stretches first this time, and reflections, and then the translations. And see what they do. So work on that. When you're done that, you're done.